Alright, this is lesson 65 for 8th grade, and today we're talking about similar triangle applications. And what we're going to do with this, you will see, is that similar triangles actually help us figure out some distances or lengths that might be kind of hard to figure out directly. So let's kind of take a look at that. Direct measure is when you actually look at something, such as a line segment, and if I asked you to come and figure out its length, you could just come up here with a yardstick or a meter stick or some sort of ruler and measure out and figure out how long it was. That would be easy. This is something that we could measure just on the board and figure out how long it is. However, we're going to have instances where we can't just do that. And that's where indirect measure comes into play. And we do that using similar triangles. Remember, similar means that the angles are all the same and that the sides are proportional. So that is to say, if we had a, let's say let's do a 6, 10 triangle. This could be a 4, 3, 5. Alright? Proportional means that corresponding sides, if we divide them, we should have the same ratio. So 8, and the side that corresponds to that is 4. 8 divided by 4 is 2. So if we do that with the other corresponding sides, we should get 2. 6 divided by 3 is also 2. 10 divided by 5 is also 2. And that's good. That means we're proportional. Okay? That's what proportional sides means with similar triangles. Okay? So let's say, for instance, we didn't know that that was an 8. And all we knew was that we had two triangles that were similar, and we were only given that. And they wanted us to find x. Well, here's what we could do. We could set up a proportion. Knowing that they're similar, that means our proportion or our ratios should be equal. So corresponding sides, if we divide them, should be equal to each other. So if I do 6 divided by 3, or 6 over 3, x divided by 4 should be the same thing, just like we did before. And that's not the only way you can set it up. You can set it up a different way if you want. You could do 6 is 3. 6 is 3 as x is to 4. Either way, we would get the same answer. Let's check that. Alright, cross multiply divide. We get 6 times 4 here is 24. 24 divided by 3 is 8. And we already knew x should be 8. We did that from the beginning. How about this one? Cross multiply. 6 times 4 is 24. 24 divided by 3 is, once again, 8. So it doesn't matter how you set your ratio up as long as you keep things lined up. So 6 and 3 either have to be directly above and below each other, or they have to be directly across from each other. Okay? So we have to keep things, we have to keep sides next to each other. 6 or 3 next to each other vertically, or 6 and 3 next to each other horizontally. Same thing with x and 4. Alright? So you can set it up however you want, as long as you keep those order things in check. Okay. So let's take a look at some examples. I have 2 of them for us. This would be an example of something we couldn't just go out and measure, at least very easily. Okay? So we want to know the height of a flagpole, and this young woman stands a meter stick in a vertical position and finds that the length of its shadow is 120 centimeters. At the same time, the shadow of the flagpole is 30 meters long. How tall is the flagpole? So this is an example, and this can actually be done, where you use shadows to help you figure out the height of something else. And the reason we can do this is because it involves similar triangles. The angle of the sun comes down at the same it comes down at the same angle for anything that's shown at that time. So for instance, the shadow of the meter stick, which is 100 centimeters, 100 centimeters in a meter. So the meter stick has a shadow of 120 centimeters. The pole has a shadow of 30 meters. We can relate these two things because the shadow angle is the same for both things. The sun's coming down at them at the same time. So here's what we have. We have our meter stick and its shadow, and then we have the pole and its shadow. So pole right there. Okay. Now the only issue with this one, and we're going to use proportion again, we can't relate this to this yet. And the reason we can't do that is because the units are not the same. This is in meters and this is in centimeters. We have to get everything into common units first. So I think it's easiest to turn things into meters. There are 100 centimeters in a meter, so this turns into 1 meter. And 120 centimeters would be 1.2 meters. So 1 meter, 1.2 meters. And what we can do now is relate. These two sides relate to each other, and these two sides relate to each other. So we can do this where we go 1 over 1.2 equals P over 30. Now remember, you don't have to set it up that way. Just make sure either the things that relate to each other are with each other horizontally or vertically. So the other way you could have done it, 1 over P equals 1.2 over 30. That's another way we could have done it. But really it doesn't matter. It's just however you want to do it. Make sure that it is lined up correctly. And what we would do here is cross multiply. 30 times 1 is 30. 30 divided by 1.2 is well, we would have to move this over 1 and move this decimal over 1. And then we'd have 12 goes into 300. So 12 goes into 300 twice. Subtract and we get 60. 12 goes in there 5 times, and that goes in there evenly. So our pole is 25 meters tall, about. Alright? So that's how we use indirect measure to figure out how tall the flagpole is. Alright, let's take a look at one more example. This one's a little more involved. It is actually example 2 in the textbook, and all I have is the diagram, so I'm going to fill in some things that we need to know. So this is example 2 in the book, and we have a couple things here that we need to point out. Josh is trying to figure out the distance across this lake. Okay, he's got 2 points directly across the lake from each other. And he's also got 2 points directly across from each other right here with a string with stakes. Okay, so Josh knows this distance right here, and it says that that distance is he walked 10 yards. Okay, so 10 yards. And he also knows this distance right here. He measured that out, and that is 8 yards. Alright, and the other distance he knows is this one right here. 45 yards, I believe, what it says. And if you notice, if you're reading along, example 2 has a lot of information. Okay, so what is nice to do is to fill it in just like I did here, so that you know where everything goes, and not try to just remember it or just do it in your head, because that's not going to help. Alright, so what we're trying to figure out is the distance across the lake. And if you notice, we have 2 triangles. and they are similar because this angle is the same in the small one as it is in the big one. So we have this red triangle right here, right triangle, and we know that this was 8 yards and this was 10 yards. And then we have the big triangle, okay, this one. And I won't draw it as big. Okay, we're looking for that distance, that's P1 to P2, and we know that this is 45 yards. Okay, so they are similar triangles because this one is inside of this big one right here. If I were to draw it in, it would be down here somewhere. Alright, so we can relate the sides once again. Now, this one relates to this one, and 8 relates to this side. So we write our proportion. We have 8 over 10 we can do, and we just need to make sure we match up with the corresponding side. So x corresponds to 8, and 10 corresponds to 45. And what we can do there is cross multiply, divide again. We do 8 times 45. We get 40. 8 times 4 is 32, plus 4 is 360. And then we do 360 divided by 10, and we should get 36. 36 meters. So it should be 36 meters across. Let's make sure we got the right answer here. Oh, not meters, yards. Sorry about that. Keep our units the same. Alright, so 36 yards across from here to here. And if I check, it is a pond. I said lake earlier. I thought that was a very short lake. So yes, it is a pond, 36 yards across, and that's how we use indirect measure to figure that out.
Yes.
Thanks.
Jacob Blair to the office, please. Jacob Blair.